So we're going to look in this video at amplitude and what effect that has on my graph. You can see here that I have a parent function for sine graphed right here, and in this particular case we're showing an amplitude of 1. Okay? Now what happens if I change this 1, which is this number right here in front of sine, what happens if I change that number to 2? Notice what happened to my graph. It's the green line. That's the second function that we graphed. Notice that it's kind of stretching my graph out, isn't it? It's making my graph taller here for a maximum and longer here down for a minimum, isn't it? So if I were to graph, I don't know, let's graph 3. That stretched it vertically even more. What happens if I change it to a small number? Let's say, I don't know, 1/3. The red line is our parent function, and this time we are flattening it, aren't we? So the amplitude, or my number, which is right in front of sine, is actually going to change either my graph by stretching it vertically or compressing it vertically. Okay, so let's see. Going back to our notes, we can see that anytime we have this letter, we call it A for amplitude. Anytime that changes, we're actually changing the range of our function. Okay, right? The range being the maximum and the minimum values. That's what we're doing when we change the amplitude. Let's do that one more time. Only this time, let's take everything back to normal, and we're going to look at what happens when we talk about a cosine function. So if this is my cosine function, are we going to be stretching it again by changing the amplitude? Let's just look at this. Notice that my original cosine function, the parent function, the maximum value it had came to 1, but by changing that amplitude, we stretched it to a 2. If I change that to a smaller number, again, we are compressing or flattening out my graph. So that's basically what I have drawn and represented for you in the notes. Oops, sorry. Drawn and represented for you in the notes. One thing I want to point out, notice every time I changed the amplitude, the areas, the x-intercepts, did not change. So all I'm doing is really stretching this vertically or compressing it vertically in between my intercepts, my x-intercepts. So let's look at this first example we have here. It says y is equal to 4 sine x. We just discussed that the amplitude of my function is always going to be the value or the coefficient in front of my function. The coefficient in front of my trig function. So in other words, the amplitude of this function is 4. The maximum it's going to rise is 4, and the minimum it's going to drop is at -4. The other thing we need to know about a sine function is that its period is normally 2 pi, meaning that when we graph this function, we're looking at the interval between 0 and 2 pi. So let's take a second. I'm going to scroll up here, and I want to show you our sine function. Every time we graph a sine function, we only have to graph it using 1, 2, 3, 4, 5 points. The parent function, the points that I start with at the very beginning of all of my sine functions, are going to look like 0, pi over 2, pi, 3 pi over 2, and 2 pi. So that period again was between 0 and 2 pi, and these are how it breaks up. These are the intervals it breaks up to. Knowing that at pi over 2 we have a maximum, at pi we cross the x-axis, at 3 pi over 2 we have a minimum, and at 2 pi we come back to the x-axis. And we always start this parent function out at 0, 0. So if we know, and notice those as I scroll through this, those were all the quadrantal angles that we learned in the beginning. Right? So if I get a sine function to graph, I start like this. I draw me out a segment right here. I know that this is going to be between 0 and 2 pi. Halfway between 0 and 2 pi is pi. half of 0 and pi, well, that's just pi over 2. And if I am incrementing by 1/2, in other words, to get from 0 to pi over 2, it's by pi over 2, then I can come and add pi over 2 to this value, and I end up with 3 pi over 2. So this is how we're going to start laying out our x-axis or our intervals every time we graph a function, either sine or cosine. The next thing I need to address is the amplitude. The original sine function had an amplitude of 1, but for this function I know that this is going to reach a maximum of 4 and a minimum of -4. And that's all I have to do besides going back and actually plotting the points. Sine functions always start at the origin. So they always start on the x-axis. They have a maximum at 4, in this case, back to the x-axis, the minimum, and back to the x-axis. And once we get our dots drawn, it's just connect the dots. So we're just going to draw or sketch my curve. And these are curves, they're not lines. And that's just the basic sine function that's been stretched with an amplitude of 4. And that's how we're going to do amplitude. The next video is going to talk to you about the period of a function.